Hi, this is Tom, and in this video we are going to continue with one more example of finding the correlation of a data set. So we're actually going to do two things. First, we're going to make a scatter plot, and then we're going to find the correlation. So I have this interesting data set that we collected in a class, and here it is. It's the shoe size of a student versus the number of keys that student carried. For example, the first student, we'll call it student 1, wears size 15 shoe and carries 3 keys. Or here's a student, here's student 2, student 3, 4. Here's an interesting student. This student has a shoe size of 9 and only carries 1 key. Yet here's another student with shoe size of 9 that has 7 keys. That's quite a bit different there. 6, 7, 8. Looks like we had 9 people that day that wanted to participate. For example, student 7 wears size 10 and has no keys. How do they do that? Well, let's see what the picture looks like, and then we'll see what kind of a relationship there might be. All right, so here we go. We're going to graph these as shoe size. This will be our explanatory or independent. Or independent variable. Or we also call it, that'll be our x's. And then our number of keys, these will be our response. Or, response or dependent variables. And we'll call that the variable y. Okay, so x is our horizontal axis and y is on the vertical. So here we go, like that. And there's our y. There's our x. So here we go. Our smallest shoe size was a 9. So let's start at 8. Well, you could start at 9, I guess. So here's 9, 10, 11, 12, 13, 14, and there's 15. And remember, these are our shoe size, or x. So we have 14, let's finish numbering, 13, 12, 11, 10, and 9. And then we have our number of keys. We'll put that over here, number of keys. And remember, these start at 0. So normally, oftentimes 0 is put right here on the x-axis. But in this case, I'm going to raise it up because it's just easier to see. So we'll start here at 0. And I have my heavy carrier is 7, so I have to go up to 7. So 0, 1, 2, 3, 4, 5, 6, 7. There's our 7-key person and everyone in between. So with that, let's start graphing our data set. All right, here we go. Actually, red and orange kind of clash. We'll use the purple. Our first person has 3 keys. Size 15 shoe. So there's one data value. Our next person is size 10 and has 1 key, size 10. Now remember, if you have graph paper, you don't need to do these dash lines. I just do them since I have a blank screen. It makes it a little easier to keep things in line. Our next person is a 12-5. So they have size 12 shoe and carry 5 keys. Here's my 5. Big dot there. That's our 5s. We've got a 9-1. So this person's size 9, 1 key. We've got a 9-7. Whoa, that person goes all the way up to 7. Then I have a 10-1. Oh, I've got 2 of those. So I'm going to just put here a little. There's different ways people might denote it. I'm going to put a 2 here, or maybe sometimes you'll see people put a circle around it since there's 2. Actually, I like the circle, so we'll do circles today. So if I had a third one, I'd put another ring around that. Let's see. So those are 10, 1. We have a 10, 0. 10, no keys at all. And then we have a 9.52. So that's going to be right in here. And a 10.5 be right between 11 and 10. That person goes all the way up to 4 keys. Okay. There's our data set. And I'm going to just shrink it down. Here's just to make it a little easier to work with and fit some stuff on our page. Really like that feature. Okay, so let's put a line on this. So, wow, well, when I look at this data, I'm not sure where a line would go. Maybe a line would go through there. But then this dot on the right's kind of lovely. Maybe, what if I went through like that? And I have to admit, I'm not really seeing it. Well, let's find out. Maybe I just can't see it, or maybe it's not there. So let's do this the same way we did before, and we're going to make a table. So I'm going to put my table right here on the right of it, and let's begin with that. So for example, here's the first person, so that one, that will have, we'll do it, so student number. Our student number, and we'll have our x's, our y's, our xy's, our x's squared, and finally our y's squared. And this will give us our table that we need. Okay, so let's see. Our first student 1, they are 15. Their keys are 3. So if we multiply that, 15 times 3 is 45. 15 squared is 225. And 3 squared is 9. Okay, so let's keep going. Student number 2. Student 2 is 10, a 1. 10 times 1, that's 10. 10 squared, 100. 1 squared, 1. And then, let's see, so here we go, student 3. I might be making this a little large here. Hopefully we can fit this all in. Student 3 is a 12, a 5. So that's 12 times 5 is 60. 12 squared is 144. 5 squared is 25. Okay, our next one is 9, 1. So that's student 4 is 9, 1. 9 squared, that's, 9 times 1, I'm sorry. 9 times 1 is 9. 9 squared is 81. And 1 squared is 1. Our next one is a 9, 7. Student 5 is 9, 7. So 9 times 7 is 63. 9 squared is 81. 7 squared, 49. Student 6. Student 6 is a 10, 1. So 10 times 1 is 10. 10 squared, 100. 1 squared, 1. 7. 7 is a 10, 0. So that'd be 10 times 0, that's 0. 10 squared is 100. 0 squared is 0. Student 8 is 9.52. So 2 times 9.5 is 19. 9.5 squared, that's going to be, well, if it was 10 times 9, it'd be 10925. Let me delete 90. 90, sorry, I misspoke. 90.25. 2 squared is 4. And then our last student, number 9, is 10.5. 4. Multiply those together, that would be 42. That would be 110.25, and 4 squared is 16. Okay, there's our table. And now we want the sum of all of these columns. Now I've done this ahead of time. And our first column totals to 95. Our second column to 24. Our third to 259. Our fourth column is 1031.5, and our fourth column is 106. Now, we're ready to calculate the correlation value. So I'm going to take this again, let's shrink it down. Oops, I meant to, let's undo my nice line there. Let's do it this way instead. I'm going to shrink that down. Oops. Oh, sorry about that. There we go. Shrink that down there. And now we can calculate R. Well, remember that R is, and I'll write it again because I think it's just good to see it. R is, and let's bring it up a little bit. Oops. Shrink that down again. So R is N times the sum of the xy's minus the sum of the x's times the sum of the y's. And then we're going to divide it by the square root, divided by the square root of n times the sum of the x's squared minus the sum of the x's squared times n, sum of the y's squared minus the sum of the y's squared. Okay, and we're actually going to stop there and come back for the next video, and we're going to find out what R is and what it means. See you in a moment. Thanks for watching.